Today I will be solving this problem here, and so here you can see at the origin here, and then we have an elliptical motion going around, and at each of these times, T1 through T4, there is a change in position, there's a change in velocity, and there's a change in displacement overall. And so here is the first question of it, and it asks for the position of the vector at T1. So to get to that answer, we go from the origin and we go in the direction of T1. So that's going to be in this direction. So if over here, these are our answer keys, we're going to put 8 for our answer, because going from here to that direction is the same as going to 8. And for the second part, it's asking for the displacement between T1 and T2. So the direction going from T1 to T2 is straight down. So our answer for that will be 5, as that is the same as this arrow here for 5. The average velocity between T1 and T2. So average velocity, which we can write over here, average velocity is equal to velocity 1 plus velocity 2 over 2. So if we have the combination of these two vectors between T1 and T2, what we need to do is we need to add the two velocities together. So we have T1 plus, and then we're going to have end to end. So here's T2. And when you add those two together, you have a different vector, which is just showing the average between the two. And if we actually draw it out, the two going this way, then the average is going down, as you can see here. So the average between the two, because they both have the same y component, but they have equal and opposite x direction components. So we can tell that this answer here will also actually be 5. So now it's asking for the average velocity between T1 and T3. So we have our T1 again, and we have our T3. So as you can see here, they both have equal and opposite force or velocities in opposite directions. So what's going to happen here, we're going to have, so 9 is 0 magnitude, and 10 is need more info. So for this one, because they're canceling each other out and it's asking for the average between the two, it's going to be 0 over 2, which equals 0. So for that, we're going to have to put 9, because 9 is 0. Then we have the average velocity between T1 and T4. So let's sum those together. I'm going to write it up here. T1, and make sure we're doing those end to end. So as you can see here, we have equal and opposite y components of it, but our x components are in the same direction, so that will actually be right there. So that's going to be answer number 7, because that's also going in this direction. The average velocity between T1 and T4. And then we finally have the average force between T1 and T4. And for that, we're looking at what our average force is. And so we have average force. And in this case, you need to take, so it's between T1 and T4. So going from T1 to T4, what component had to change? So going from T1, and then your next component is T4. And the component of that changed between here was because our x component, as we can see from before, was the same when we were looking for the average. So going in this velocity direction to going here, our change in force is going to be positive up. So that's going to be our answer 1. So we're going to write that in there. And that is your final answer for that.